Hello students, Jai Hind, Jai Bharat. Once again welcome back to your class Ravi Sarji Maths, the easier and natural way to learn the concepts of mathematics. Students, in our previous video lecture we have learned various topics regarding the matrices. Students, in this video lecture we are going to learn how to find out adjoint of matrix having different order. Students, if you are new to this channel, just subscribe and don't forget to hit the bell icon, right? Okay, now students, first of all we will know the definitions of adjoint of matrices. Adjoint, how to find out adjoint of a matrix. For that your concept should be clear. If you don't know the concept how to find out adjoint of matrix, you can't do anything, right? So let us move on to the definitions of adjoint of matrix, right students? Okay, for a given square matrix A, right? For a given square matrix A, if we replace every entry, in A by its cofactor, very important term students, cofactor, right? In modulus A. Modulus A means student determinant A, right? And then the transpose of matrix, right? Again, what you have to do? Transpose of matrix so obtained is called the adjoint of A and denoted by adjoint A, right students? Okay, let us move with example. Suppose, right, you have a matrix like A, right, and its element in form of AI and suppose order n by m order, right students? Otherwise n by n order, right? You want to find out transpose of matrix A. So transpose of matrix A, students, in the previous video lecture you have learned convert the row into column, and here you want to find out what? Adjoint A. So adjoint A can be written as A, the cofactor of A, right? Cofactor of A. Suppose cofactor of A, I and J column. Its transpose with the same order, right? N by n order, right? N by n order means students the number of rows and number of column will be equal, means you will have to take any square matrix. Okay students, let us see over here. Suppose you have a matrix like A having element A11, A12, A13, A21, A22, A23, A31, A32, A33, right? You want to find out adjoint of A, right students? So adjoint of A, right? What is adjoint of A? So you can find out adjoint of A by replacing the cofactor of A11. Suppose the cofactor of A11, A12, A13, right? Similarly, the cofactor of these elements, it will be A21, A22, A23, and the cofactor of all these elements will be what? A31, A32, A33, and taking the transpose of this matrix, you will get what? Adjoint of A. Okay students, let us practice these things with example. How can you find out cofactor of an element of a matrix. Okay, suppose a matrix A having element like 1 2 3 2 1 2 4 3 1. Right students, you want to find out adjoint of this matrix. What do you want to find out? Adjoint of this matrix. So first of all student, you can compare all these things by A11 is student 1, A12 is what 2, A13 is what 4, right? A21 is 2, A22 1. Similarly students, what you first of all your target is to be what? Find out A11, right? Find out A11. So first of all here you can see that you will have to convert this matrix into determinant, right? Into determinant. So determinant A 1 2 3 2 1 2 4 3 1. Right students? Now you will have to expand these things. To find out cofactor, you will have to keep it in mind the sign conventions of all these elements. Okay, any matrix A always in the form of plus, minus, plus, again students minus. So according to this sign convention you can expand any determinant, right? But students, our target is to what? Find out cofactor of all these elements. You want to find out cofactor of A11, right? Similarly A12, A13, okay? So students, here you can see that the cofactor of A11 is what? Capital A11. Cofactor of A12 is what? Capital A12, and similarly, right student? So your target is to be what? First of all find out A11, right? You want to find out A11. So how can you find out A11? Okay, first of all students, you will have to take minus. Now you can see that for A11, this is first row and first column. So 1 plus 1, right? If you remove all these things like that way, so finally you are getting what? A, 2 and 3, 1. Right students? Now A is to the power minus 1 is to the power 2. Over cross multiplication students, you know the Cramer rules. 1 into 1, 1 minus 2 into 3, 6. So finally you are getting plus over here. So minus 5. Right students? Similarly you will find out, you have found out A11. Similarly you will find out A12. A12. A12, right students? This element. Now you can see that this is the element of this determinant or matrix, first row and second column, right? First row and second column. So minus first row and second column. Now accepting these things, right? Accepting these things, you can take what? 2 3 3 1. So minus 1 whole is to the power 3, okay, using the Cramer's rules. 2 minus 9, so this will be minus 1, and here you are getting minus 7. So the value of A12 is minus 1 into minus 7 plus 7. Okay. Similarly students, find out A14, A13, right? This is the element of A13. A13 is 4. You want to find out cofactor A13, capital A13. So capital A13 from here, minus 1, first row, third column. First row, third column, right? Now accepting these things, you will write all these elements 2 1 and 1 2, 2 1 and 1 2, right? So this will be minus 1 is to the power 4, 4 minus 1, right? So plus 1, here you are getting 3. So the cofactor of small a13 is what? 3. Right, students? Similarly, you will find out this element, cofactor of 2. Cofactor of 2 means what? You will have to take this element and this element, right? So A21, A21. You are taking A21, so you will have to discard this element and these elements. So elements will be what? Minus 1, second row, first column. You are removing these things and these things, right? So you are getting 2 2 4 1, right? So minus 1 is to the power 3, and here is 2 minus 8, it is minus 1 and minus 6. So finally you are getting, students, 6. So the value of A21 is 6. Similarly, you will find out the cofactor of 1. So according to the cofactor of 1 means you will find out the cofactor of A22. Means discard these elements and these elements. So you will write A11, A31, A13 and A33. So A22 means second row, second column, 2 plus 2. You want to find out 1, cofactor of 1. So these elements and these elements. So you will get 1 3 and 4 1. 1 3 4 1. So positive even power over here, so minus 1, so it will be plus 1. Cross over here, 1 minus 12, so you are getting minus 11. Right, students? Now you can find out cofactor of 3. Cofactor of 3 is what? A23. A23 minus 1, second row, third column, 2 plus 3. So these elements will be cancelled out, these elements will be cancelled out, right? So you will write 1 3 and 2 2. 1 3 2 2. So minus 1 is to the power 5. 2 minus 6. Minus 1 will be there. And here will be minus 4. So minus 1 minus 4, you are getting, students, 4, right? Now cofactor of 3 means A31. A31. You want to find out the cofactor of A31, discarding these elements and these elements. So A12, A22, A13, A23. So from here you can write what? Minus 1, third row, first column, means the element will be 1 2 3 1, right, students? Okay, so minus 1 is to the power 4, cross multiplication, 1 minus 6, so plus 1, you are getting minus 5, right? Okay. Now we will find out the cofactor of A32. A32 means cofactor of 2. So cofactor of 2 is what? A32, capital A32, capital A32. So minus 1 is to the power 3 plus 2. Okay. So these will be cancelled out, these will be cancelled out. So finally we are getting 1 2 and 4 3. 1 2 4 3. So minus 1 is to the power 5, cross multiplication, 3 minus 8, minus 1, 3 minus 8 minus 5, Finally you are getting what, student? Plus 5. Okay, now you will find out cofactor of A33. The cofactor of A33 is what? Capital A33. It means you will find out cofactor of capital A33. So A33 means -1, third row, third column. So the elements according to these things, you want to find out the cofactor of 1, 1. These will be cancelled out, these will be cancelled out. 1, 2 and 2, 1. 1, 2, 2, 1. Okay, student. So -1 whole is to the power 6. The cross multiplication will be there, 1 minus 4. So -1 is to the power 6. You are getting 1 and here is -3. So A33 is what? -3. Right, students? As per the definitions of adjoint of matrix, Aij is what? Adjoint of a capital Aij of transpose, right? So transpose of A, adjoint A is what? A11, A12, A13, A21, A22, A23, A31, A32, A33 of its transpose. Right, student? Now writing the elements of all these things A11. Now students, here you can see that what is A11? -5. Okay, so writing -5. Now what about A12? A12. What is the element of A12? 7. So writing 7. A13. A13 is 3. A21 is 6. A22 is 11, -11. Then A23, the value of A23 is what, student? 4. Value of A31, right? Value of A31 -5. Value of A32, value of A32 is again +5, and finally value of A33 is -3. Okay, the adjoint of A means transpose of this matrix. It means you will convert all the columns into row and all the row into columns. Okay, these rows converted into column, -5, 7, 3. Now this row converted into column, 6, -11, 4, and -5, 5, -3. Okay, students, this is a process how you can find out adjoint of matrix with order 3 by 3, means 3 rows and 3 column. Students, I hope you have understood this video lecture. For more video lecture of this topic, keep watching your channel Ravi Sir Ji Maths. Thank you so much.